Let's look now at the Assessment Navigator component. So in this component we are able to create our assessments, and at the moment it's largely in the form of multiple choice questions, and we can see here a bunch of questions, and these questions are actually variations on 4 main questions. We'll find that the system auto-generates questions, it randomizes numbers and various other aspects of the question, and it generates answers based on those numbers that have been randomized or options that have been selected. So let's have a look at what happens when we undertake an assessment. So the first question, acceleration, is defined as, and we know the correct answer here is rate of velocity. We'll choose that. We do have the option to declare our confidence in this answer, so we're 100% confident of that. And we can write here a comment about our answer as well. So that's the first question. In this next one, we've got a Humvee of mass 2 tons traveling at about 10 meters per second. What's the momentum? That's of course then about 20,000. So let's just mark that. Similar question here. You can see it's very slightly different to the other one. So this time it's a Mercedes-Benz instead of a Humvee, and it's got a different mass and a little bit of a different velocity. So here it's likely this as the correct answer. And now here's a different question. We've got a Fiat Uno of this mass. Well, that's heavy in comparison with that, but anyway, that's a Fiat Uno of this mass traveling at about 10 meters per second and accelerating at 2 meters per second squared. When will it reach 20 meters per second? So 20 minus 10 is about 10 meters per second, so this is going to take about 5 seconds. So that's about the right answer there. And now let's go and choose some incorrect answers. Acceleration, let's just put that as rate of change of displacement, which of course is velocity instead. And this one is about, what is this, 1.9 and 6.3, so I'm going to, let's put that at a high number here, so that should be wrong. And then Susan drops a watch from the top of the Eiffel Tower, and let's choose the speed of light instead. Okay, so we've got a collection of correct and incorrect answers here, and we click on submit, and then we can see now the system is giving us immediate feedback. So it's agreeing, yes, this is the best answer. Rate of change of velocity is acceleration. Here it's saying this is the best answer, so yes, this is correct, and so on. So these are all the correct answers. And here, where we've chosen rate of displacement, so it says here, this is not the best answer, and it's explaining that, well, this is the rate of change of, or rather, this is velocity. So in red, that indicates the incorrect answer, and in the green, this is not set up well. We'll see just now how we set up the answer. And here also we chose the wrong answer, and we've got a proper explanation of what you should actually do. Down here we haven't provided any answers, so we didn't really complete this, so we didn't accumulate any scores there. You can see in places where we got the answer right, it's given us a score of 5, and that can change depending on your confidence in your answer as well. But let's just simplify it for now, and that's how we can undertake an assessment. And we can see that we can really generate many variations of the same questions, and so a student can really master a section by undertaking this training and getting this immediate feedback. So in contrast to a test or an exam where there's a long feedback loop, here there's immediate feedback, and you can keep practicing these until and using the explanations until you really understand the topic, and so the assessment is facilitated by this method. So let's look now at how we can create these questions on the system. So we head over to question design, and you can see a wad of text here that shows all those questions and how they've been set up. So to simplify things, I'm just going to copy out here a simpler variation of one of these problems. So let's just take the simple text one first. So here we have the problem statement. Acceleration is defined as. So yes, we state our problem here with the attribute of problem statement. So this is what's known as a JSON object, JavaScript object notation. So in this JSON object, we need the square braces around everything, and that's because in JSON we have square braces telling us that it's an array, and then curly braces which means it's an object. So in this object we have an attribute called problem statement, and here our problem statement reads like that. And then we also have problem modifiers, which we'll come to just now. For now we're keeping things simple, so let's ignore problem modifiers. And then here answers. So we again have an array in the square brackets, and then we open up curly brackets for an object, and here we have the attribute of score. So the first answer has a score of 5, and here we find the correct answer. So we have to have a value attribute, and that must return the rate of change of velocity. So we want to return the correct answer here, and here we can change this a little bit. Acceleration is the rate of change of velocity. Well, in fact, this problem is a bit too simple. So maybe we could just write something symbolically. So we can say A equals du dt. And here we say that this is the correct answer, so we specify category is best. A second one here, score is 0 if you choose rate of change of distance for acceleration. So that's not acceleration, so the score is 0 there. And the comment here, this is speed rather. It's saying that the rate of change of distance is speed, so it's trying to explain why that's not the correct answer. And of course, this example is just illustrative. You can write far more extensive comments here in explaining to a student why something is correct or not correct. And there's a last answer as well. So you see, for the simplest possible type of question, this is we can just define various answers to that problem. And if we say update questions, and you'll see it puts everything on one line here. This is the same JSON object, it's just now on one line. If you go to self-assess, you see now it's all the same question everywhere. And we do have a reordering of the answers. So you see that the answers are in different orders, but at the moment, that's the only variation, right? There's no variation here in the actual problem statement, because of course it's just a string of text. So let's look now first at creating some variation in this question. So here's a second one. And by the way, it's useful to create these modifications and to edit your questions in a JSON editor. So it just helps you with the indentation and syntax highlighting and so on. So now we want to create this problem. Some variable name drops some variable object name from the top of some variable building on a still day. It falls at an acceleration of. And you see we've got these variations, name, object name, and building. And here in the problem modifiers now, it's no longer blank like before. Now we have under name, we've got 5 possible names. And for the object name, we've got 3 here, and for the building, also 3. And here, well, there's no change. It's just going to change the text here. It's not going to change the answer, because in whatever variation of this problem we pose, the acceleration is always going to be 9.81 meters squared per second. So you see here the first answer, that's the answer, right? And we can test this out. So let's just choose this. So I'm just going to copy this in the question design. And okay, let's append it to the other question. So I'm going to add that in there. Update, and right, so now you can see we had the other question there, which was just the definition of acceleration, and now you can see interspersed with that we have this object dropping from the tower question, and it's random, so there's no order here. It's deliberately shuffled all these questions. And here, Chung drops a cell phone from the top of the Sears Tower on a still day. And of course, the answer there is that one. And then here, Karul drops a cell phone, well, Sears Tower again. Yep. And well, that's my son's name, so he's come up quite a bit. But anyway, acceleration is the rate of change of velocity. And so you can answer all these questions, and if you say submit, then where you've answered it correctly, you get the score, and so on. So that's variation, where we are just changing the text in the problem statement. Now, a little bit more interesting. We want to change the answer in addition to modifying the question. So here's a nice problem. A certain car type of a certain mass is traveling at a certain velocity. What's the vehicle's momentum? So in the car type, we've got Audi A4, Mercedes-Benz, Fiat Uno, Humvee. So that's just going to change the text. But here now we have the mass of the car. So M car, that's the car mass. Now we'd like to generate a number within a certain range. And let's say we want that range to be 2 tons to 3 tons. Then we specify here min to max of 2E3 and 3E3. So that's kilograms, SI unit. Well, never mind SI units. Here it says the mass of the car has to be kilograms. So in the text of the problem, it's kilograms. So something I didn't say is that the modifiers have to be within these angle brackets, right? So you've got M car in the angle brackets, and the system is going to generate a random number between these extrema. And for the velocity of the car as well, we are taking a value. I guess here I was going on 20 kph, so 20 kilometers per hour. That's going to be so 20 kilometers to meters is 20 E3, and then that's per hour. We'd like it in seconds, so divide by 3,600. So that's the minimum, and then that's the maximum. And then in this case, I want to constrain this a little further. So here I'm also specifying the number of decimal points. So dec P, that's shorthand for decimal points. So we want just 1 decimal point here. And that's going to be enough to give us a number. And we want to know what's the vehicle's momentum. So in this case, of course, the answer is dependent on the values here. Right? It won't change with this, but it's going to depend on these 2 numbers. And so in our answer now, instead of returning just a string, right? If you look down here at this answer, this was returning a string, right? This was a constant 9.81 meters per second squared. Whereas here, we are doing a little calculation first. So you can see the momentum P equals the mass of the car multiplied with the velocity of the car. You'll see also this little OBJ dot. So that's because this string is going to be used in the creation of a function which is going to send in an object which we'll call OBJ, and OBJ is going to contain all these attributes. So it will have car type, M car, U car in there, and so we can use those variables in our definition here. So this is how we can create a little program that calculates for us the answer. So we are specifying that in the first answer it's going to have a score of 5, and the value is going to be determined by that calculation. And that will be the comment if the person gets it right, and we are marking this as the correct answer or the best answer. Here we are designing our distractors. So it's incorrect if we say that the momentum is the mass divided by the velocity. It's also incorrect to say it's 0. We can see from the ranges that we are specifying the answer can never be 0. So that's going to be incorrect, so a score of 0. Also infinity, we are constrained in the maximum here as well, so it can't be infinity either. So these are all incorrect answers. And so this is how we can create a problem that has an answer that's determined by the modifiers in the problem statement. So let's have a look at that. So here under question design, just pasting that text in there, and we say update questions, and here we can see some variations. So a Mercedes-Benz of that mass at that velocity, an Audi A4 of that mass at that velocity, and you see the numbers here correspond with the values that are now stated in the problem. Right, so that's how you can create variations in questions. And here's another one. I don't think there's anything really new to learn here. It's just a slightly more extended question here. You've got a car of some variation mass is traveling at some variation initial velocity, and it's accelerating at some variation acceleration value. So when will the car reach this variation final velocity? In other words, how long does it take to get there? And so in this one, the answer is, of course, the time is the difference between the velocities, the final velocity and the initial velocity, divided by the acceleration of that vehicle. So here all those numbers are generated in the same way that we described a little earlier. So we can have a look at that here. So again, update questions, and then we go to self-assess. And so you see all the variations created, all the options available. So we go click, click, click on our answers, and then submit. And then we get the scores after that. So if we include all these questions together, right, in this array, so I'm just going to paste that in here and update, then there's a randomization that happens. So the system randomly chooses among those questions, and it randomly positions all the answers in each of those questions as well. So you can create a lot of variation, and you can tweak the ranges and so on. I use slightly tight ranges, so that's why I'm not getting as much variation. But you can create a lot of variation in your questions, and as you add questions, you create more resources here. So that's really the first part of the assessment navigator. So as students choose to engage with this material and undertake more questions, then their activity becomes logged, and the system shows that they are quite engaged with the material, and it encourages them that, well, you are ready now to move on to the next concept and so on. So this component on assessments, it links to the other component, the concept scaffolder. What was that called? Well, in the concept scaffolder, we could navigate multiple concepts. So this is a question set for a particular concept. All right, so that's how you can create online testing for students with automated feedback, and so students can use this to assess themselves and really practice plenty of problems.